We'll go ahead and start. I'm thinking we're doing 2 sections in each section, so you need to look at your outline. Most of your questions are going to come from chapter 7, I believe, because that's the most important. Go ahead and write down the 5, 6 objectives on the board. I mean, you don't have to write down word for word. Just distinguish between discrete and continuous. Identify discrete, graph discrete. And these are probability distributions. So it's kind of like the, hold on a second, I'm going to have to go to my whiteboard. While y'all are writing those down. Before, in the first section of the class, we were doing statistics. And I told you that when you did statistics, you have 2 types of data. You have like test scores, 42, 36, 55, and you average them up, you get the mean and the standard deviation. Okay? And I told you that's data driven. And then I told you that we can find also with a frequency distribution, we can find the same thing. 18 to 22, 5. 23, 18, 19, 20, 21, 22, 4, so that's going to be 26. 4 is 27, 4 is 30, and we have 4 and 3 here. And then I told you we could find the mean and the standard deviation of a frequency distribution. So now we're doing probability with a probability distribution. So the probability distribution is going to look something like that. Okay? It's going to look like a frequency distribution. So, not trying to confuse you with what we're talking about, but when they talk about a probability distribution, they're talking about something that looks like this, only instead of a head count, you're going to have a probability. And that's the difference between a probability distribution and a frequency distribution. And we're going to compute the mean, and we're going to compute the standard deviation, just like we did with a frequency distribution back in Unit 1. Capiche? A random variable is a numerical measure of an outcome of the probability of distribution, so it's determined by chance, random, blah, blah, blah. A discrete random variable has either a finite or countable. Okay? Discrete. What did we say discrete was back in Unit 1? Discrete means that you can what? Count. Discrete means you can count. Discrete random variable has either a finite or countable number of values. The values of a discrete random variable can be plotted on a number line, just like that. And this will make sense in just a minute. A continuous random variable means decimals. Decimals and what else? Fractions. Distinguish between discrete and continuous. Determine whether the following random variables. The number of light bulbs that burn out in a room of 10 light bulbs in the next year. Well, that's discrete. Think of light bulbs as eggs. And what's the number one example of discrete that I gave you in Unit 1? Eggs. Because you can what? Count them. What's the example of continuous that I gave you in Unit 1? Measuring the height of a tree. Anything you measure. Count is discrete. Measure is what? Continuous. The number of leaves. Number of leaves is what? Number means what? Count. So it's discrete. The length of time. Well, time is one of those things that what? I told you that question that they asked that time, we got into a discussion about it. Time is measured. Okay? If you hit a stopwatch, if I give two of you a stopwatch, and I tell you to mark how long it takes to hold your breath or whatever, you'll have two different readings because you'll start to watch at different times from each other. Okay? So time is continuous. And time, anything having to do with time, is always going to be weird because you can't control it. Even though some people try to. Capiche? Okay, that's what it looks like. And notice you see the same thing you saw back with the frequency distribution. You have a table. Battery's dead. And back then, you used to have the class or the category up here. And then you had what over here? You had the head count. But we're not doing that now. Now, X is how many games or how many whatevers. How many games will it take to win the World Series or I don't know how you would say this, but 0 games, 1 game, 2 games, 3 games, 4 games, 5 games. Or that could be how many times you throw the basketball in the hoop. What's the probability that you miss it? 0.06. What's the probability that you hit it 1 time? 0.58 out of 2 times, 22%. 3 times, 0.10%. 10%. 4 times, 3%, and 5 times, 5 baskets in a row, you're going to hit 1%. Okay? So these are things that are happening, like games, like basketballs in the hoop. I don't know. You'll see a better example when I do one. They should have gave you one here, but they're not. Okay. Number of movies streamed on Netflix each month. 0 movies, 0.06. 1 movie, 0.58. 2 movies, 0.22. 3 movies, and so on. So this is going to be the number of items. Okay? And this is the probability of that event happening. So, well, that's interesting. I'm going to tell you today, I don't feel like this today. I'll just cancel class and we'll just quit. I just don't feel like it. Yeah, that's what y'all say, but one person will call and complain to the department head. What's the number one rule of life? There's always what?
There's always one.
There's always one. It ain't going to be you, but you'll be the first one.
Nope.
Yeah, you would.
I really did pay for 2 hours of math, and we only talked for 15 minutes.
Okay. All good.
All right. To make a long story short, this is the probability, and this is the event. And here, the event is the number of movies streamed on Netflix. Sorry. Okay, that's X. 0 movies, 1 movie, 2 movies, 3 movies, 4 movies, and 5 movies. Your probability is on the right. Now, there's 2 rules about probability. What's the 2 rules? 2 or 3 rules. Each probability has to be between what? 0 and 1. Therefore, it has to be positive. And all the probabilities together, added up, should equal what? 1. Now, some books say 0.99 to 1.01. You have to look at this book and see. You'll probably tell on the slide here in just a minute. But some books say 0 to 1. Some books say 0.99 to 1.01 for this part right here. Okay, so we'll see in just a minute what this book says. So if you add all these up, first of all, are all these positive? Yes. So you can keep going. Are all of them between 0 and 1? Are all of them between 0 cents and $1? Yes. If you add them up, let's see what we get. Well, 58 and 22, that'll make that a 2. That's 80, 86, 96, 99, and $1. So yes, it equals 1. So this has to equal, if the summation, your summation of your P of X has to equal 0.99 to 1.01. Remember, some books say 1.00. It depends on what your book says, and you slide here in just a minute. We'll probably say that. So be able to, you may have a homework or a test question. Does it add up to 1? I like to give those, 1, to make sure you know what you're doing and make sure you're paying attention. And 2, it's an easy 5 or 10 points. Okay? Don't wish for it, work for it. Is that what it says?
It is, yeah.
Yeah, it's kind of like losing weight and being in the weight room and all that, wishing for it, and that's no.
Relatable.
Shut up, Hubert. Everybody, I'm energy, I'm fat, and you say, okay, you need to lose weight. I don't want to do that.
Then you gotta quit eating pizza.
Yeah.
Man.
I'm not going to say anything. Shut up, Hubert. All right, rules for a discrete probability distribution. There they are. I just showed them to you. Now this one says 1, right there. If you add all the P of X's up, it's got to equal 1. I want you to also remember some books put 0.99 to 1.01. Evidently this book is saying that it may have a note down at the bottom or something that says 0.99 to 1.01 or something. And each probability has to be a positive decimal or fraction between 0 and 1. That's the test I just gave you on the previous slide. Okay? So look at this one. Do they all match? Yes, they all between 0 and 1. But it does not relate to a probability distribution, because if you add all those up, you only get 97 cents instead of $1. So that one would not be, and that would be a test question or a homework question, because like I said, it's to see if you're paying attention, and also it's an easy 10 points. Okay? So that could be a test question, and the answer would be no. It is not a probability distribution because it equals 0.97, and it should equal 0.99 to 1.01 or 1. That one is not a probability distribution because it has a negative. You cannot have a negative probability. That's like having a negative area, or going to Atlanta and saying, oh well, I'm going back to Anderson, I got to travel negative 200 miles. How many times you seen a highway sign with negative 200 on it?
Negative. Never.
You never. Because distance cannot be negative, area cannot be negative, and probability cannot be negative. Capiche? So that one's a no. So that could be a test question. If you get it wrong, you don't what? You don't tell anybody. Oh yeah, I got that one right. All right. that's a probability distribution. So all three of these could be test questions. And somebody's going to miss them. All right, so that one's yes because all of them are positive between 0 and 1. If you add them up, you equal $1. I'm not going to ask you to do a histogram very much because to me that's not really the only reason you do a histogram is to see if the probability shows any type of a curve. But I really don't do a lot of histograms. That would be a homework question, but not necessarily a test question. All right, write that down. Here's number one important formula. The mean is equal to the summation of x times the probability of x. Or the Marlboro Blacks. Now everybody's smoking the Marlboro Blacks.
Those things won't turn.
Oh, huh?
So they smell. I mean, they smell better than some other things, but you know.
I just watch live TV. I just thank God every day my parents beat the crap out of me, so I do become a live TV person.
That's what I'm saying.
Not that they had to beat the crap out of me. They didn't really have to do much because I was a pretty good kid. I was. I didn't do anything unlawful or I didn't backtalk or do anything like that because my daddy was bigger. My daddy was bigger than I was. Bigger than I am now. I mean, he's a pretty big fella. All right. And he was the disciplinarian. My mother was the switch holder. My father, he's the one that popped the belt. So, and I'm deranged and crazy and violent. That really did affect me and really make me crazy. Don't even get me started. Time out. Hubert, go sit time out in the corner. That wouldn't have worked. All right. All right, so what I mean here? Well, the X is the event. And the P of X is the probability of the event. So that means I just take the first column and multiply it by the what? By the second column, Hubert. And then add them all up. Okay, so if I got a column here, they're probably going to show it on the next P of X. I'm going to add a third column. And I'm going to add that column. I'm going to do it in blue. And that's going to be called X times what? P of X. And let's say I have a 0. Let's go back to red. Let's say 0, 1, 2. And I got a probability of 0.25. And I got a probability of 0.25. And I got a probability of 0.50. Everybody with me? All right. So now I take X, and I multiply it by P of X, and I get this column over here. Things I do for y'all. 0 times 25 cents is 0. 1 times 25 cents is 25 cents. And 2 times 50 cents is what? And what I do with those three numbers? Add them up. That's what that sigma means. So my mean is 1.25. And what did I tell you about the mean and the standard deviation in statistics and probability? They're most important what? Numbers. So that's one of your most important numbers. We're going over a test question right now. We're going over several test questions right now. Where X is the value of random variable and P of X is the probability. I just showed you that right there. Okay? So I just found the mean of a probability distribution. All right, and I want you to do it on your paper. Don't do it. Do not look at the bottom of this page. All right? The reason I don't want you to look at the bottom of the page is because some people get confused with looking at the bottom of the page. All right? So we're not going to look at the bottom of the page. I'm not even worried about it. Just don't look at this, okay? I want you to draw a column and put the X. I want you to draw a column and put the P of X. And then I want you to draw a third column, and I want you to label it what? P times what? P times X. P, X times P of X. If I could get this God-blessed thing to start working again. Russians. X times what? P of X. Don't worry, the world's going to hell in a handbasket now. If you watch the news, it's going to hell in a handbasket.
That's why I don't watch this.
Because one of the Supreme Court justices is retiring. Hell in a handbasket. How old is the United States? Well, 1776 from 2018 is what? I do that on your calculator.
242 years?
I guess 242 years since the organization of the United States. I just wonder how we're going to make it through the next 4 years. We made it 242 years. I'm being sarcastic. Some of y'all might have. All right, I'm going to do the first two for you because I feel led to show you how smart I am. 0 times 0.06 is 0, and 1 times 0.58 is 0.58. Now you do the rest. Aren't y'all impressed with my mathematical abilities? I could actually do the third one. 44. Some of y'all might do the third one without a calculator. I don't know. We do have people that can't spell mom backwards. But 3 dimes is what? Oh my Lord. Oh my gosh. 4 times 3 cents. And 5 pennies is what? Don't tell me America's getting dumber. Y'all are smart.
We're just getting lazier.
No, lazier, that's it. Y'all need to watch that Waters World and watch him interview people on the beach and ask them what July 4th is for.
Oh my gosh.
It will make you want to go out and hit somebody in the face.
What was that? There was a video.
One guy said it was because we won the Civil War.
Ooh. Oh my gosh.
How can people be that dumb? Anyway, now, here we go. We're going to do some more math here. 44 cents plus 30 cents is 74 cents. But I don't want to do that. I want to do 88 cents because that's easier to. That's 88 cents right there. So I'm going to add these two up because they're bigger. You could add this one up plus that one, and that'd be what? $1.02? That'd probably be better. $1.02, $1.32, $1.37, $1.49. Somebody help me out.
It's $1.49.
It's a miracle. So you just found the mean of that probability distribution. Piece of cake. Now eventually these numbers are going to get more and more tedious, and I'm going to pull out the Excel spreadsheet. You would put it in your what? Calculator. But I'll have to look and see if you can multiply L1 times L. Yeah. You can do L1 times L2. But I don't know what it will give you. We'll have to research that. Unless the calculator drill team members in here can tell me. We'll cross that bridge when we get there. It says compute the mean of the probability distribution to the right, which represents the number of DVDs a person rents from a video store. Do they still have video stores?
Family Video.
You're kidding.
I go there every bit. It's more fun.
No. Dang old, my DVR full of movies I like. Dang old. I got about like 50 movies that I got recorded.
More movies.
My dadgum
That's why you buy the DVD.
percentage that I can record is like 2%.
Oh.
I can't record anything, so I just record SpongeBob for my kid. So I can't record no more movies unless I delete one, and I ain't gonna delete one, so I'll just leave it at 98%. What?
Just go buy the DVD.
No. Then I have to hook up the DVD and see if it, I don't even know if I can find the remote to it. I hadn't used it in so long. Anyway, a person rents from a video store. So you got about a 1.5 as far as the mean. So the mean is right in here. 1.5 videos, which means around 2. So that's your mean. Next, what do you think they're going to ask for after you figure out how to do the mean? The standard deviation. And then everybody's going to start crying because the formula looks all bad and tough, and everybody's going to get intimidated. Interpretation of the mean. I don't know what this is. Suppose an experiment is repeated in an amount of times. As the number of repetitions increases, the mean value will approach. Okay. You need to, I don't care what you write here, but you need to remember this. The mean value of the n trials will approach mu sub x. You need to write that down. They're going to ask you some questions about what is the mean doing, and the answer is going to be whatever it contains, the letter that contains, or the answer that contains the mean value of the n trials will approach the population mean. How did I know that's population mean? Somebody tell me. How do I know that's population mean? They don't say that in there anywhere.
Because it's a Greek.
Good job. You're the one that listened that day. Okay? It's a Greek letter, mu. And that's exactly why you need to know why the parameters versus the statistic. If that was an x bar sub x, you would say sample mean. And therefore, you don't sound ignorant in a presentation. What's that silly looking upside down U? You know, then you sound like Billy Bob. Okay, especially in a room full of know-it-alls. The mean of the random variable x. In other words, let x of 1 be the value of random variable x after the first experiment be the value of the second, blah, 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 and so on. The difference between x, the difference. Difference means what? The distance between the two. Gets closer and closer to be equal as n increases. Write that down. So you need to write down the mean value of the n trials will approach the population mean that you calculate, or the difference between the sample mean and the population mean gets closer as n what? Increases. Those are the two things that you need to look for in your answers. You know, your Philadelphia lawyer answers that they ask you. The ones that you don't know which end is what. That's what you're looking for. Those two things. So highlight those two sentences. You'll see when we go over some homework problems. So anybody seen Hereditary yet? No, I guess
Horror
not.
movie?
Yeah,
No.
I want to go see it.
I went and saw Jurassic World.
Yeah, I did too.
That's
It
epic.
was-
Who's no city opposite.
I don't care.
I still like the first Jurassic Park. This is one time where the first movie was better than all of
You
them.
talking about the first Jurassic
Incredibles
World?
is the same
No, the first Jurassic Park.
Well, that beats them all, of course.
Yeah,
You can't
because-
remake an original.
Well, the second one and the third one really. And the Jurassic World, I like Jurassic World second. And this one, it was just, I don't know. Maybe I need to go watch it after I drink a few or something. I don't know. Maybe something like that. All right, this one says, the following data represent the number of DVDs rented by 100 randomly selected customers in a single visit. Compute the mean number of DVDs rented. You would punch all those in the calculator. We're not doing that, okay? I think all of y'all know how to find the mean of all those numbers, okay? All right, and they're finding out that the X bar, now what does X bar mean? Sample mean. Sample mean is equal to 1.49. Write that down. And they got that by using, add them all up into, y'all know how to do that. Your test scores, in school, add them all, divide by 5 test scores. Same thing here. We know how to do that. Now, you're going to compare that to a probability distribution that they're going to go in the next slide. See, they're getting ready to. Hopefully they're going to. All right. Okay, they didn't. So we'll get to it eventually. Go ahead and write this question down right here. This is a standardized test question, and it's also a test question, and it's also a homework question. So you need to write it down and put it in your notes. The reason is it's because the way it's written, a lot of people, what do they do when they see it? Huh? They freak out. Some people don't even freak out. They just what? They just skip it. Why? Because it's got too many words in it. Actually, it's real simple. In life, there's only 2 or 3 things you have to do. One is pay taxes. The other is live or what? Die. All right, now let's take out pay taxes. Then, what's your chances of living? Well, you can walk out today and there's a 0.5 chance you may die. Okay? There's a 0.5 chance that you may live. All right? But this one even tells you, okay, what the probability of somebody living is. So it gives you that probability, and all you have to do is find the complement. Now, luckily, it's not 18-year-old males, because the probability of 18-year-old male living is not 0.99791. What do you think the probability of a 18-year-old male is living, surviving? About 0.89. Why? Because they're stupid. Okay? But a 49-year-old male or a 49-year-old female is not stupid. Okay? They don't drive their car 500 miles an hour down the interstate. Okay? They don't drive their car 80 miles an hour in a 35 mile an hour zone. Okay? So they tell you here that somewhere in here, there it is, it said the probability the female will survive the year is 0.997. Okay, highlight that sentence. Highlight the sentence that says the female will survive the year is point blah, blah, blah. That's the first thing that you start with. Because you've got to set up a probability distribution. And it's real simple. You either live or you what? Die. We still out paying taxes. Okay? So there's only 2 things that you can do in an insurance policy question. Live or die. So you put live on the top, where it says survive, I put live, and then die on the bottom. Live or die. Now that's not politically correct, but I don't care. Okay? You either live or you die. Alright, so let's go over to the probability of living or dying. It tells you the probability of the survival of the woman is 0.99791. So boom, probability survive or probability live, E of X is 0.99791. Therefore, what's the complement? Well, 97 cent or 99 cent from $1 is what? 1 cent. So it's going to be less than 1 cent. So it's going to be 0.00209. And where did I get that number from? It's the complement of what? Okay, what's the complement of living? Dying. What's the complement of dying? Living. So if the survival rate or living probability is 0.99791, then the die-in probability is 1 minus 0.99791, which is 0.00209. So the first part of this question is for you to make the table, put dead, live, and put the probability for live and the probability for dead right here. That's the first part of the question. Now the second part of the question. If you pay an insurance company, and I'm just going to talk out loud, if you pay an insurance company $500 a year, and you live for that year, you're out how much money? $500. So that's what it's saying right there. If you survive the year, you're out $530. Everybody with me?
Yeah.
But if you die, somebody gonna get some money. And that means the insurance company ain't gonna keep it. So they're out how much? Well, the $530, they got your payment. Okay? But they're gonna pay out to your family $250,000. So in essence, they're gonna pay out negative $249,470. Now you've got to understand, this is from the aspect of the insurance company. Okay? And that's what it says, the term life insurance policy will pay. They're looking to it from an insurance company. So there is your event, 530. 530 means that I survived the year. Negative 249,470 means that I'm dead. Okay? Probability of me living is 0.99791. Probability of me being dead is 0.00209. So, what did I tell you the mean? Multiply 530 times 999, and you multiply negative 249,000, then you add them up. And when you do that, you get what? $7.50. Okay, now let's read the question. A term life insurance policy will pay a beneficiary family a certain sum of money upon the death of the policyholder. These policies have premiums that must be paid annually. Suppose a life insurance company sells a blah, blah, blah one-term life insurance policy to a 49-year-old male for female for $530. According to the National Vital Statistics Report, Volume 47, number 28, that's very important that y'all know that, the probability the female survived the year, blah, blah, blah. Compute the expected value of this policy to the insurance company. And the expected value is $7.50. Okay? Now the expected value is what that policy is worth to the company. Because life insurance companies are not going to sell you a life insurance policy if you, 18 years old, smoke 3 packs of Marlboro Reds a day, diabetic, and you've been in jail for the last 15 years, off and on for the last, not 15 years, but the last 5 years. Are they going to give you a regular life insurance policy, or are they going to give you an expensive life insurance policy? Expensive, because you have a higher probability of dying than a 49-year-old woman or a 49-year-old male, because most of the time, a 50-year-old female or a 50-year-old male aren't stupid. But you do have 40-year-old males that cruise small. Okay? We won't say what they are, but anyway, you do have them, correct? And you have 49-year-old women that try to dress up like their teenage daughter. But we won't talk about that either. But there's exceptions to the rule. Most 49-year-old females are not stupid. Okay? Females grow out of their stupidity, what? 18, 21? Yeah, somewhere in there. Guys, sorry. I'm not even going to talk about it. Question. There we are, standard deviation. And I want you to write down this one. I want you to write down that one. Now I want you to read it after you write it down. Standard deviation, population standard deviation of x is equal to the square root of the summation of x squared times p of x minus the mean squared. Now, I don't want you to just read it and look at it and stare at it. I want you to try to understand what it's saying. Do we have P of X? Yes or no? In a binomial distribution, a probability distribution, do we have P of X? Yes. So we don't have to calculate that. Do we have the mean? Yes, we just calculated the mean. So what's the only variable up there that we don't have? That's not rhetorical. I'm asking y'all to interact with me. X, what? X squared. So you're going to have to make another column, not called P times X, but you're going to have to make another column now called what? X squared. All right? They're probably going to give us an example on the next slide, and we'll do it there. I'm going to do it on an Excel spreadsheet, and I want you to do it in your notes. Okay? There we go. This might be the one we did a while ago, is it? Somebody look in your notes. Where we found the mean?
Mm-hmm. Yeah.
Okay, so you can go back to that one if you want to, if you've got room on that page, or you can just say continue from the previous page, or you can rewrite it. But I want you to have on this page where we're doing standard deviation, I want you to do your X column, I want you to do P of X, and if you're not on the previous page that we did with the mean, I want you to do the third column. Is going to be called what? X squared. Fourth column is going to be called x squared times what? P of x. Now while y'all are doing those columns, I'm going to pull up the Excel spreadsheet so we can do it that way. So we got x, we got p of x. I'm going to just go ahead and do everything. So I'm going to go over here and I'm going to put x times p of x. And then I'm going to go over here and I'm going to rewrite x and p of x. And then I'm going to go over here and I'm going to put x squared. And then right here, I'm going to put x squared times p of x. All right, what does it go from 0 to 5? 0, 1, 2, 3, 4, 5. Okay, and give me the first probability. 0.06. 0.06. Sorry. 0.58. 0.22. 0.10. 0.03. 0.01. And of course, the first thing you would do when you start one of these problems is hit the little summation bar and check to make sure, and it's 1, so we can keep going. Here we're going to find the mean. So I'm going to take equals this guy times this guy and enter. And I'm going to copy down. And I'm going to copy this guy, Control C, Control V, and there's that. Over here, I'm going to say equals to this guy, and I'm going to copy that down. And equals this guy, and copy that down. And here we go, equals this guy, raised to the second power. I'll do the first one for you, it'll be 0. And copy that down. And here I'm going to take this guy and multiply by what? P of x. And copy that down. And Control C to make sure I don't copy something else. Control V. I get 3.09, but that's not my variance or that's the first part. Okay, because we got the mean right here. Here's the mean. There's the mean. But down here, to get our variance, we've got to take that number and subtract the mean what? Look at the formula. What do we got to subtract? The mean what? I'm sorry, I couldn't hear. Squared. So I got to square the mean and subtract it, and I get that. That's the variance. And what is always the relationship between standard deviation and the variance? It's always the square root of it, Hubert. That's right, class. And there's your answer. So here is our important number 1, and here is our important number, your mean and your standard deviation. Now make sure you understand how I just did that. Okay, because if you don't forget. And it's very important that you write down the formulas because you have to read the formulas. You can't just look at the formula and say, Hubert, what's that mean? Well, that don't tell you nothing. The mean, x bar or mu, whichever one you want to use, is equal to the summation of x times what? P of x. X times P of x. And then what is your variance? Your variance is equal to the summation of what? X squared times what? P of x. And then after we add that up, you subtract what? You subtract the mean squared. You have to read the formulas. Okay? So many students, they put down the formulas in their notebook and they say, okay, what does that mean? What do I do? Read the formula. Don't just ask me, because I'm not going to tell you. I'm going to tell you to read the formula. You take x, and what do you do to x? What do you do to x? You square it. That's what I did right there. And then you take x squared and multiply it by what? P of x. That's what I did right there. And then what do you do to that? You add it up. And there's that number right there, which is 3.09. And then minus, parentheses, squared, and that's 1.49. And that's the variance. Now, ever since the first unit, I've told you that the variance, take the square root of the variance, and that's your standard deviation. If you're given the standard deviation, you square it, and that's your variance, if you've ever asked for the variance. That's it. Now, right quick, I'm going to change up the numbers, and I want you to put it in your notebook for a second example. I want you to calculate it. I'm going to go over here, and I'm going to change that 0.01 Change that 0.25. Change that 0.3. Change that let's say 0.7, let's see. That's 0.55, 0.56, 0.04. That's 0.6, 0.2, and 0.2. All right, I'm gonna give y'all 4 minutes. And you should be able to get the same numbers that I'm getting. I want you to draw your columns real neat and organized so you'll know when you get home, when you're doing homework, what to do when you get stumped. Can y'all see the numbers?
No.
No. How's that?
That's fabulous.
Is that better?
Yes.
Prima donnas. The campus are prima donnas. They're divas. I ain't kidding you. There's some people that should not procreate. I'm sorry. Facebook. I mean, you get some people.
Good answer.
I'm sorry. Okay, let's say that and there's a reason that I'm talking about this, because I've been doing the keto diet for about almost a year. August will be a year. Okay? And I've lost like 85 pounds. Okay? But before I went on the diet, I did like 2 or 3 weeks of preparing, of researching, writing notes. Okay? There are people on Facebook that go into diets and they haven't done the first bit of research. I'm on a couple of, what do you call them, pages, groups, just to see if I could help somebody. And I can't help some of these people. I mean, they just, can I chew chewing gum?
Are you serious?
Oh, yeah.
Of course you.
What can I do? What can I do? Can I still drink coffee? How much water should I drink?
How about don't just.
I just don't understand. I just don't understand how somebody can go on a diet and not even research the diet, not even. Nobody has any comments. Okay, I'll just shut up then.
I mean, that's how it works. Just the next day you wake up, you feel some way, and you're like, let me do this.
Yeah.
Where's my...
I'm going to Disney World. What can I eat? Oh, I need to show you these comments. I mean, how can you?
For the past 10 weeks.
What?
So they gotta eat the same thing they've been eating for the past 10 weeks. Why they
Oh
gotta worry about
yeah,
it?
I need to go and go to my and just live. It just amazes me. I just quit replying. I mean, you can only take so much stupid. Let me see if I can pull up. Let's see.
It's just me. I just give a smart ass answer back. Just to mess with them.
Okay, here's one. I seem to be having a really hard time getting into ketosis. I am not sure how to find out what my macros should be. There is all sorts of ways to figure that out if you go to Google and type in keto macros. Do people not understand how to use Google?
They just want you to answer their...
That's it. That's it. And I get that a lot from students. When I talk about the formulas, what I do on here, I said, read the formulas. No, I don't want to read the formulas. Just tell me how to do it. I get that from students a lot. I get that from students.
So that's why you brought it up.
Yep, I'm trying to prove a point. I'm just kidding. What are macros? I'm sorry, if you're going on a keto diet, you should know what macros are. You should research it or read a book. Can coconut milk be used instead of almond milk?
It's the same thing. What's wrong with these people?
You just don't know. I want to get to the one that's still asking if she can chew chewing gum.
Oh my God. I mean, I hope so.
You should just tell her no.
That's what I'm saying. Just tell these people no. Make their life miserable.
Yeah. Let them figure
Had
it out.
one. I'm going to quit. It's been 2 days and I haven't lost any weight.
Oh.
2 days.
A whole 2 days.
Wow.
That's a long time.
Sorry, unless you're 600 pounds.
2 days. All right, check out your numbers and see what they're coming out to. This is a test question. This problem I just gave you, asking for the mean and the standard deviation, is a test question. You'll have 2 or 3 of these on the test. So make sure you can do this type of question. Now I'm going to show you a question based on boy, girl. I'm going to show you how they set up but I want you to see how they set up a distribution, not that I will ask you to do this on a test. I think you need to see this because you need to know it for just like if you ever take a standardized test or whatever the case may be. Okay, evidently my whiteboard's not going to work now. Hold on a second. It's the Russians. There we go.
What if I ask you to set up a probability distribution of a couple having 2 kids? Of a couple having 2 kids, and given the probability of a girl is 0.52. Okay? You're just setting up a probability distribution, and you got this information that in this part of the world, the probability of a girl being born is 0.52, or this hospital, or this county in this state, the probability is 0.52. Now, when you read this question, most of you are going to sit there and go, I have no earthly idea what. Well, what is a probability distribution? Well, that's where you have a table, right? So draw a table. And this is X, and this is P of X. Everybody with me? Okay, so you don't have to sit there standing like a bump on the log now. You at least got something drawn. Okay, now the events go on the left. And most of the time we've been doing 0, 1, and 2, right? Now why am I not going over 2? There's 2 kids. 0 means 0 girls, because we're doing a probability of girl, right? That's given. 1 means 1 girl, and 2 means what? 2 girls. Now you could say boys if you want to, it doesn't matter. Okay, so this is the probability of a girl. All right, so 0 girls. That would be boy what? Boy. 1 girl would be boy, girl, or what? Girl, boy. And what would 2 girls be? I'll do that one for you. Girl, girl. So now all you got to do is figure out the probability. How you do that? Well, what's the probability of? Let's go easy. What's the probability of 2 girls? Would be 0.52 times what? Times 0.52. And 2 boys would be 0.48 times what? Somebody give me these 2, and let's round it to 4 decimal places. What's 0.48 times 0.48? 0.2304. And where does that go? 0.2304. And what's 0.52 times 0.52? 0.2704. Now somebody tell me what's unique about the boy-girl and the girl-boy. What's unique about it? Multiplication is what? Commutative. So are you going to get the same answer for both? Yes. 0.48 times 0.52 is the same as 0.52 times 0.5. 2 times 3 is the same as 3 times 2. So these 2, if you did it, what are they going to come out to be? It's going to be 2 times whatever the answer is. What's 0.48 times 0.52? 2496, and multiply that by 2. 0.4992, and that goes here. Now, are all my numbers between 0 and 1? Yes. Add them up, see what you get. And then find the mean and the standard deviation. That's your 3rd example for this type of question. So, I don't want anybody saying, anybody add them up yet? 50 cent plus 27 cent is 77 cent. 77 cent plus 23 cent is what? $1. Mom, backwards. M-O. NASCAR backwards is race car.
Race car backwards is race car.
Race car backwards is race car. Yeah, there you go.
Taco cat backwards is taco cat.
Yeah. Let's spell mom backwards. Can't do that. Yeah. All right, now I'm going to erase this, and I want you to find the mean and the standard deviation. You've already set up your probability distribution. Now you need to do mean and standard deviation. And you might want to put in your notes how to create a probability. That's what I just showed you how to do, how to create a probability distribution. But you're not going to be asked that too much because you're not going to be given the information to do that, because sometimes it can be a little tongue twisting or brain twisting. Can I eat Chick-fil-A on the keto diet?
Oh gosh.
Did they?
Why don't we just all go to pizza buffet together too?
These are what people ask.
But these are all people.
I would just have like a copied message that you put in your notes. If you do not read before, do not ask me questions.
These are all people who want to lose weight.
Should I
but
drink
just can't.
beer or light beer?
Oh my God. Okay, if you're going, this is my dad's rule. If you're going to get your calories in a good way, it's either going to be beer or ice cream. So.
How about
But the keto diet
no, just to make them mad.
But the keto diet is anti-carb, and what is beer?
Carbs.
Carbs.
Just no beer then. Drink water.
Actually, it's better if you drink hard liquor than put beer. Beer is like anti-keto, period.
So liquor's better.
So what you been doing?
But you don't sit there and drink a whole bottle.
Wine is fine, but liquor's quick.
Yeah, exactly.
It's
You're
true.
doing too much.
Sorry, what?
I'm going on vacation. What can I eat?
Just tell them not to eat anything then.
I'm telling you.
Oh my gosh, I'm going to make this.
I would mess with them. So
I'm going to make a
much.
keto taco tonight. Taco is made out of cheese.
Cheese, meat, bread.
No, you fry the cheese and you get it caramelized.
What the heck is wrong with these people?
That's nice. I don't want to do that.
I don't know how to eat healthy.
Okay, y'all ready for this one?
Yeah, I don't
Yeah,
know.
I'm actually
I
ready.
think.
Is canned tuna or salmon okay for the keto diet?
I really don't know that.
It
Yeah,
depends.
any meat
I
is
think
good as long as you don't fry it.
It depends.
Okay. I ain't done my research because I don't plan on going on this diet.
I just like when I chose a diet, I just decided to go with the Japanese diet.
I'm good.
Food, vegetables.
I'm just going to go on the bourbon diet. Anybody want to go on the bourbon diet or the tequila diet? Let's go on the tequila diet.
I've never tried.
Don't do any research. Just go out and just drink all the tequila you can drink. You know.
Okay.
I mean, it sounds good, but you know. Next morning, might be like,
People,
I
I'm
ain't
kidding.
tried it yet. How about vodka?
And we need to, and people are debating whether you want to legalize marijuana in South Carolina.
yeah, that's
We have
that sounds like a
people
great
that are dumber than dog poop and can't spell mom backwards, and we need to legalize marijuana for recreational use.
Recreational use.
Yeah, we need to really dumb down our millennials. They're too smart. I'm not talking about for medical use because I know there are advantages, but I'm talking about for the deadheads. We don't need more deadheads out there. All right, I'm going to do this one for you, 0. And x times p of x is 0.4992. And this is going to be 54.08.
Yeah.
54.08. And let's see, 54 cent plus 50 cent is $1.04. So it's going to be around $1.05 somewhere. What is it? Add them all up. What do you get?
1.03.
Okay, 1.03. And that's your what? Mean is equal to 1.03. Did y'all get 1.03? Yes, Hubert. No, Hubert. Thank you for the support,
It's 0.04.
class.
I'm sorry, I was wrong.
Thank y'all. Appreciate it.
I tried to do it in my head.
I must have offended somebody with a deadhead statement. 1.04. All right, now what? Well, now we need another column. What's that column? X what? X squared. I'll do this for you. 0, 1, 4. Y'all are impressed, aren't you?
Mm-hmm.
X squared times what? X squared times p of x. And I'm going to really concentrate here. 0, 0.4992. Oh, I may not be able to do this. 4 times 25 is $1. So that's $1.08.
$1.08.
It's a miracle. 0.8 what?
1.6.
Okay. And 50 cent, that's $1.58. But what does it come out to be?
158.08.
Now, that is the first part of the formula. Notice I'm not putting variance or anything in front of it because the formula says I've got to take that number and subtract this quantity what? Squared. So I'm going to go over here and I'm going to put variance is equal to, and I'm going to put 1.5808 minus parentheses 1.04 quantity squared. And that's going to be 1.58 minus 1.16, which comes out to be what? 0.42? What does it come out to be? I may be way wrong. Somebody do it for me. What do you get?
Doing the 1.04 square?
Yeah. So the whole thing comes out to be what? 0.4992. And now we're going to take the square root of the variance, raise it to the 0.5 power, and somebody give me that number.
This is 465.
7065. And your two most important numbers are standard deviation and so what is the most common between having 0 girls, 1 girl, or 2 girls? What's the most common? The mean is what? 1. So what's most common? 0 girls, 1 girl, or 2 girls? Think about it. Would that be most common? Yeah, because it makes up what? It makes up 50% of the probability. So yes, that does make sense that 1 girl is the average. Easily settle down. I'm going to have to get them to drink some Mountain Dew up there. Y'all need to get Mountain Dew Code Red before y'all come to class. No, I don't even think they heard. I think they've got me muted. I really do. I think they mute me. I think they do.
They don't
It was-
stop talking to me for some reason.
Huh?
It's giving me a complex.
She said I think.
I'm gonna have to go out and look at the truck. Let's see. Okay, I don't want to do this yet because that's 6.2. Let's go ahead and quit today and we'll cover 6.2 when y'all come back. Some of y'all are still finishing up homework. When's the test due? When's the homework due?
Tonight.
Okay, so y'all got to finish up tonight and the homework, and I will see y'all when?
Thursday.
You don't have class tomorrow, so. All right, y'all have a good day, and try not to ask stupid questions. Don't wish for it.